meaning we're gonna do test case design. You'll be able to use that for testing and also code reviews. So for the theory part of it, we're gonna go over functional, non-functional testing, test case design, code reviews, and then we have just a couple of slides introducing what is static code analysis and software metrics. And then we have a discussion. We have not been able to cover it earlier on, so probably we're not going to have enough time. So that will be for next Tuesday. So, done reading the cartoon. Midterm. I knew some of you were not going to be here on Tuesday, so I have it again. Same slide. So November 3rd, next Thursday, during regular class time, make sure you attend exams for your respective section, meaning the section you're officially registered to. Duration is going to be an hour on the dot. So if you come here 5 minutes, 10 minutes, 30 minutes later, you're still going to finish at the same time as everybody else. So make sure you're not late because you're not going to get extra time. Everything that is was covered in class until QA1, meaning everything until lecture up to and including lecture 11, except some slides where QA1 stuff that's not going to be covered in the exam. I'm also not going to give you any practitioner interviews, the one that I've been uploading. These are going to be for the final exam. The exam, the midterm, is going to be scenario based. If you remember the hockey, you had a little scenario and then you had to draw a diagram. So you're not only going to get diagram, you're going to get the theory part of software engineering. So I'm going to ask you some questions, what software architecture, blah, 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 you're going to be using for that scenario. Draw some diagrams based on this scenario. So it's important that you practice a diagram. Make sure you bring pencil, not pen, because else there's going to be a lot of scratches and things like that. I don't mind if you use a pencil and you draw the diagram. So yeah, that's regarding the midterm. Questions? Do you still have questions following that? Yeah.
Can you provide us with past questions or anything like that?
Just quickly cover exactly what's not going to be on there. The interview.
Quality assurance, starting quality assurance is not going to be on the midterm. Yeah, and these a couple, is it 2 or 3 practitioner interviews? Yeah. So normally, if you have, you study the lecture notes. We did exercises as we went along, right? So if you practice those exercises, there's these IBM articles for UML designs and things like that. So pretty much, the scenario is going to be different, of course. So you want practice for the midterm, practice these diagrams based on scenarios we've covered in class, because the scenario is going to be just completely different from, but it's going to be exactly the same sort of question. You're going to get a scenario just like the hockey league, and I'm going to ask you to draw a diagram. So you don't need to practice for the scenario, you just need to practice how to draw the diagram, proper notations and things like that. The scenario is going to change for the midterm and the exam. You need to understand the concept behind, the different, you need to understand the different concepts in software engineering and how to draw these diagrams properly. You'll be fine. It's not a long exam, it's just going to be 1 hour with about 7-8 questions. I think so, but it's not going to be long. And the questions are going to be very short, 4 or 5 lines answers. If you find yourself writing more than 4 or 5 lines, then you're probably going to run out of time. Questions should be short, concise. So I'm not expecting you to write essay style answers for you for yeah.
So on that note, then is like bullet point form okay?
Yeah, bullet point form is okay. It makes my job easier when we grade. I'm not going to be the only one grading. We spent like a whole day with all the TAs. There's about 200 of you, so all of us grade your midterms and final exams as well. Okay. So if you have more questions, you can ask me. That was the end of class. So let's start with functional and non-functional testing. So this is a little bit continuing with the theory of software testing. So we already talked about different types of testing. We saw unit testing, integration testing, system testing on Tuesday. So the other type of testing is, one of them is regression testing. Who can tell me what is regression testing? Have you ever heard of the terminology? Regression testing? No? You've heard of it, but have no idea what it is. Okay, so normally, you have multiple versions of your software, right? You're going to build an early version, you're going to add things on top of it, and so on and so forth. So every time you add things, you make changes, you modify something, you need to test again to make sure that whatever you have added hasn't broken, existing code, or whatever features you've added, modified, hasn't broken, or even removing stuff, haven't broken existing code. So this is called regression testing. So basically, when you fix something, you would want to make sure you test again. So it identifies new faults that may have been introduced as correct one or removed, or new features are added, etc. So because these are pretty exhaustive, you want to test everything. These are often automated. And in industry, it's a very common practice that you're going to be coding during the day and then you're going to run the regression. I don't know if you've heard the terminology, but regression test suite during the night, and then the next day the developer's going to come back and look at the error log and see what has broken, what has passed, and things like that, and then they're going to fix what has broken. So this is basically regression testing. You perform it after you've made some changes, after you've modified stuff, you've added stuff, etc., just to make sure that things are working properly after these changes. It's important to maintain a proper versioning of your software. If ever you mess up really bad, right, you make changes and you crash the whole code base, you can revert back to the last, sort of stable version. We talked about integration testing. On Tuesday, anybody remember what this is? What is integration testing? Yeah.
Testing the systems.
How do you test the system?
Testing the connection between connecting the testers.
Yeah, you don't test the entire system, not at the first. Unit testing, you'll be testing the individual components, modules, subsystem, whatever you want to call it. And then integration testing, you'll be adding sort of components which are related together and seeing whether they are working fine or whether things are breaking. How would you know what components needs to talk to each other, needs to work with each other? Which one? Which of these components are connected or working with each other or has a relation with another component? Where are you going to look at that? Where are you going to find this information? Yeah.
Is there a high-level diagram?
Which one? There's a lot of diagrams we've talked about.
The bone diagram.
Just the UML class diagram.
Not the class diagram. The class diagram you see only a snapshot for one particular, sort of class. You're not going to see all the components. You're going to see the classes. I'm not talking about classes. I'm talking about components. A component can contain multiple classes, can contain multiple modules. Yeah.
The component diagram.
The component diagram, which you just submitted, a few days ago. This is where you see the relationship among your different components, right? So here we're talking about actually connecting these components. So how do you know whether A needs to talk to B, B needs to talk to C? Through the component diagram. Guys, you need to study for that midterm. Okay, so integration testing is basically, like you have these different components which you have tested as a developer at an individual level. So now I have tested something, he's tested something, and both our components need to work together. So now we connect those, and two things can happen. Either everything works fine or it breaks. Now I need to figure out why it's breaking and fix it so that it can work, right? So one thing to remember in integration testing and also in general software development, sometimes we are using third-party components, sometimes we are using third-party libraries, sometimes we are using off-the-shelf software, which is going to be integrated with software that we build in-house. So you also want to test the, integrating your software and these sort of third-party components. It's not always your component A and your component B. It's also going to be your software and what has been implemented or what you bought ready-made. And these are all sort of off-the-shelf components. Or even if you're using from past project, like sometimes you're using some modules, some component from past project. So these projects have been, in the code base for so long, and you don't know how they're going to react when you integrate it with your system. So this is also where, a good opportunity to run integration tests. So we're going to look at two particular types of integration testing, and we're going to base ourselves on this sort of diagram. So let's say these are the different subsystem modules, components, etc. that you have in your system. You can see 3 different layers here. Layer 1 where you have component A, layer 2 you have B, C, D, I'm going from top to bottom, and then layer 3 you have E and G. So if you start at the bottom, the first layer is going to be E and G, second layer is going to be B, C, D, and top layer is going to be A. So here this has 3 layers and 7 subsystem, module, component, whatever you want to call it. So there's 2 ways you can do integration testing. Either you start at the bottom or you start at the top. So here, bottom-up integration is where you start at the top. So I've sort of reversed this particular diagram here. So if you see, we're starting at the bottom, meaning we start with component E, F, G. So you have these 3 components. Do you see that component E and F is integrated with B? So at the first level, you would be testing these components individually, meaning you would be doing unit testing. And then you would take E and F, you would integrate it with B, and then you would test B, E, F. So that would be the first sort of subsystems that you would be testing. You would be integrating B, E, F, and testing. There's nothing in the middle, so nothing is connected to C. You're just going to leave it alone. And then on the other side, you see that component is integrated with D. So you would test these 2 together. So you would have basically, you finish your first level, that bottom level. So in the next level, now you have 3 components. BEF as one sort of group of subsystems. You would have C, component C on its own, and component D and G. So this is level 2. So once you finish with testing level 2, now you integrate, basically BEF is going to be integrated together, so it's going to be a big sort of thing. So you integrate that first sort of subset of components, and then you add C, and then you add DG. So when you test A, B, C, D, E, F, G, you're basically testing the entire system. So the difference with, the thing with a bottom-up is that you test these individual sort of components first, and then you keep building. One thing to remember in integration testing is that sometimes you don't have access all these components, like you're working with B and F, but you need to integrate, you're working with E and F, and you need to integrate B, but not all the functionalities are ready. What you're going to do in this case, we have, in the case of bottom-up integration, you have things called drivers. So drivers are going to be pieces of code that you're going to write that's going to simulate the behavior of components which are missing. So your test should work, but it's not, these components have not been implemented yet. So this is bottom-up integration. Yeah, you have a question?
Yeah, does regression testing ever overlap integration testing?
All the tests can overlap, especially the higher level tests. You're going to have some overlapping, that's for sure. Yeah. Top-down integration, this one you test from the top all the way to the bottom. So that means I would test component A first, and then I would integrate it with B, C, D. That would be sort of my first subsystems, and then I would add the lower layer. If there were more layers, I just keep adding until I've integrated everything. So if you see that A, B, C, D, E, F, G, this is basically the entire system. So you're going to have the same problem here. Some of these lower level components are not going to be ready yet. Then you'll have to simulate their behavior to make sure it's working fine. So in this case, it's exactly the same thing, but they are called stubs. So in the case of bottom-up, they are called drivers, and in the case of in top-down integration, they are called stubs. And this is just an example, like preventing your program from crashing, you're just going to return 0. But you're going to have something similar to that. Yeah.
How do you know which is best to use top down or bottom up for your system?
This is a design strategy that you will have to discuss as a team. So for example, when would you use bottom-up versus top-down? So let's say you started coding. Let's say a very simple example. You have a website. You started with a home page, but a home page normally will have a bunch of other pages, right? None of those are ready. So when you're testing, you're going to be testing top-down because just A is ready. You don't have BCD. All of these like smaller pages are not ready. But let's say when you implemented these, like contact page or about us, or like a product description. I don't know. Let's say we are selling something, so different products. So you all have implemented these individual pages first, but you haven't integrated everything, so they don't work with each other. They are all individual pages of the website. So then when you're going to be testing those, you're going to be doing bottom-up because these are the ones that are ready first. So it depends on your testing, your coding strategy, which one, and there's no like right or wrong, it's just basically depending on what makes sense to do first. So this is the two types of integration testing. So system testing, also we've talked about that, so this is basically testing the system as a whole. So for this one, where are you going to find information on what to test? Where are you going to find this information? How do I know what I need to test? Or what the software is supposed to do? Yeah?
Requirements.
Requirements, you're going to use that. You look at your epics, user stories, or requirement document. And you're going to test both functional and non-functional. You still remember what is non-functional? No? ELTs, the quality requirements. Example of the point of sale, I'm at the grocery store, I'm scanning this. This is supposed to scan, it's scanning, so it's fine. But if it's taking 5 minutes to scan, that's not good. So performance, accuracy, availability, all of these are non-functional requirements. Guys, you really need to study for that midterm. Okay, so these are the non-functional requirements. So things like, compatibility, load, stress, GUI, regression are all examples of system testing. So we are going to look at them a couple of them individually, the non-functional testing that we can perform. And for each of you, because your project is so different from each other, maybe, and don't worry if you don't understand these terms right now. So let's say load testing is something which is important for one team, but it's not important for another team. You don't care about having testing for different type of loads or different loads of users or different volumes or things like that. So then load testing might be applicable for one project but not for the other. But we're going to look at that in a minute. First, I want to talk about smoke and sanity testing. Have you ever heard of smoke and sanity testing? Not testing your mental health. I'm not qualified for that. So smoke testing actually comes from hardware. You know how you would build a piece of equipment, not you, the people would build a piece of equipment, and then once it's built, you would switch on that piece of equipment. There's two things that can happen, right? Either it switches on properly, or it starts a fire, it starts smoking because something happens. So that's basically a smoke test. And software, engineering, because we borrow a lot of things from other disciplines. So we borrow the terms smoke, and we have something called smoke testing, which is basically the same thing. And if you see, smoke testing is done at the early stage of development, when you have the software versions are not very stable. During the initial builds, maybe you have a couple of builds. So you're gonna just test the function, test the software, right? Like open that website, open the app, let's see what happens. If the app itself is not opening, your smoke testing has failed. So something like that, right? You've implemented, you've written some code, and then now you want to see how it looks like, and the page itself is not loading, or the app is taking forever to load, so it has failed. So the whole idea behind that is that if the basic features, after you've implemented some code, it's supposed to work. If that itself is not working, you won't spend time doing further testing, like unit testing, integration testing. It's going to be a waste of time if you can't even load the page, right? The app itself is not showing up. So you would want to fix any kind of issues that you have before you perform these more detailed testing. So that was sort of the idea. To reject the software if it's it's broken, basically. Easier way to talk about this. So if it is broken, you reject the software, it goes back into production, you fix the bug. When things are working, then you can do some more, some further testing. Sanity testing is done later. If you can see, it's we've reached build 23, so it's at the later phase of the development life cycle. At this point, the builds are pretty stable. They're not like at the start, like things are crashing here and there. So you could perform sanity testing to check whether newly added functionalities or bugs or anything that you detected previously, now they're working. And again, this is not regression testing. You're not going to test everything. You're just going to test, pick and choose, maybe things that were not working before, right? You focus on that. Or you've newly added something, some features. You're just going to focus on that. Is that new thing working? and so on and so forth. So the scope is very narrow. It's not regression where you test exhaustively, it's very narrow. Just checking a few things here and there, just making sure it's working. So once it's passed smoke testing and sanity testing, then you can go on and perform these more detailed sort of testing. Unit testing and not unit testing, system testing, regression testing, and load testing, and all of this sort of testing. We also talked about acceptance testing last time. Anybody remember what is that? You remember?
Actually, I had a question.
Okay, well, I'll continue.
But I can answer it's when acceptance tests are we're ensuring that our code passes the customer's requirements or something like that. I'm not sure.
All the tests make sure, the goal of all the tests is to make sure that it passes the customer requirements.
It's those tests we have to this is how we can concretely say that our code is working.
Why? What is different in acceptance testing? Why can you say confidently? Yeah.
Oh, this is the last phase of the testing process. You come through you're unit and integration, and so now you're trying to get out to basically all that's final fill essentially. And users are consuming.
Yes. The key here is that users, your stakeholders are involved. That's the difference. System testing is going to be performed by you people, developers. Acceptance testing, you're still going to be testing the entire system, but it's going to be done by the users. So if you got the requirement wrong, and then you're doing system testing, and it's passing, the tests are passing on the wrong requirement, that's not good. But the customer's going to catch that. Oh, that's not how I wanted things. So then you're going to understand that you got the requirements wrong. So that's why it's important, and this is something that we talk about from the start. It's important that your stakeholders, all of you have real stakeholders, right? It's important for your stakeholders to test your software. You're going to be doing acceptance testing. I see some smile. You guys have some dummy users? No real users? I want to see some real people. Don't bring some, toys and say, this is my user. Two types of user acceptance testing. One is alpha test. So alpha testing, what's going to happen is the user's still going to, let's say I am your stakeholder and you're the developers. You're going to make me come to the development website, give me a computer and say, hey, test your thing. But everything is controlled. It's going to be your environment, your software, your hardware, right? And probably it's ideal, maybe it's not going to simulate every single scenario. The real test is when, for example, if I ask all of you here, what are the different configurations that you have on your laptop? I'm pretty sure every one of you who are working on your laptop right now, your configuration is going to be different, right? Different operating system. You're using different browsers, different hardware, different software, and things like that. So the real test is when you do beta testing, meaning you are testing. Do you think you've ever been a beta tester? Have you ever downloaded a beta version of something? Then you've been a beta tester. If you look at this iOS 13, they have also a beta 5. So if you've downloaded any software which has a word beta on it, you've been a beta tester. Now whether you report the bugs that you've encountered or not, that's a different story. But you've all probably downloaded some beta version of something. So beta version meaning you're downloading something on your own environment, your own laptop, your own computer, your own mobile phone, and you're testing it in a more realistic environment. And a lot of users are, how many different combinations of, environment the software is actually being used on, being run on. A lot, right? So if all of you report errors, so they can actually use these error reports to improve the quality of the software. So that's where the word beta comes from now, if you download the beta versions of the software. So one problem with beta testing is that sometimes the versions that they publish have so many bugs that you as a customer, you lose confidence in the software. You're like, yeah, I've used this, it has so many bugs. You don't even want to wait for them to release a stable version. You just move on. You look for an alternative app, an alternative software. So you lose confidence in their software. So that can be a problem, right? They're going to lose customers. But because they're big vulnerable, they're putting themselves out there and saying, hey, this is like a less stable version, try it out and give us feedback, but instead they end up losing customers. And people who do that are people like Apple, right? So they have a lot of money, so losing a few customers, well, can be detrimental, but you know, the company's probably not going to close down. Non-functional testing. Our memory is coming back. I'm pretty sure you guys remember that nice pizza you had last weekend. So non-functional requirement, there's a lot of those, you know, reliability, availability, accuracy, etc. So make sure you're familiar with all these terms. Just a tip from me to you. Let's look a little bit. I'm not going to be able, of course, to go through each and every one, but I can give you some example of non-functional testing. And these testing are performed at all test levels. You can do it at unit testing, system testing, and so on. And all of these relate to the performance of software. So what type of testing is stress testing? So here you test the limits of the software to determine the breakpoint. So the aim here is to see, you know, how much can it handle before it breaks, both in terms of data and users, right? You will test with 100 users, 200 users. Similarly, you will test with, you know, I don't know, 100 megabyte of data, 200 megabyte of data, and then you see where it actually breaks. So for example, monitor the system behavior when the maximum number of users is logged in at the same time. And oftentimes you'll be doing this using simulation. You actually won't recruit like 1 million people to test the software, right? So you'll be doing it through simulation. Load testing is measuring performance based on a large number of users. So again, you would simulate users. And let's say, you know, you found out that your software is not very scalable, right? After, I don't know, 500 users it crashes. And you had designed your software to be able to handle, I don't know, 1 million users. If after 500 is crashing, then you will learn that your software is not scalable. You need to do something before it's actually released, right? So load testing is that based on the number of users. Volume testing is based on the amount of data it can handle. So can it handle like, you know, GBs of data, terabytes of data? Maybe that's, you know, how the software is designed to be. It's supposed to handle very large volume of data. Well, is it doing that? Again, you'll be using simulation to test all of these. The last two is configuration testing and compatibility testing. So here, if you remember the example I took just a few minutes ago, all of you have different software and hardware configuration on the computer, right? So although in a development environment, you won't be able to simulate every single possibility that there is out there, but you might be able to simulate like the most common, you know, combinations of software and hardware, and you test, you know, those configurations. So this is configuration testing. Compatibility testing is testing your software with different environment. By environment can just mean about anything like different operating system, different browsers, etc., different versions of things. So this is, you know, environment testing. Yeah.
So does compatibility fall a bit like, does the environment fall into software or not really like a...
Yes, I mean like software is more like, you know, does it work with, you know, on your computer, what have you installed? Is it going to conflict with whatever app you are, let's say I'm building a software. You're installing it on your computer. You already have, you know, your hardware you won't be able to change, but you already have software already installed on your computer, right? So is the software that you're installing that I have built going to conflict? Your, you know, whatever you have on your computer going to create some issues, compatibility issues and things like that. This is what we're talking about. Whereas, you know, environment, we're talking about, you know, I'm going to try it on, what's the browser by Microsoft? Edge? Right. I'm going to test it on Edge, Safari, Chrome. So here I'm talking about I'm talking more about portability here. You know, different operating system, different browsers, and things like that. You know, I'm going to test it on Windows, on iOS, maybe on a mobile phone, and so on and so forth.
So the question is, we're testing the app running on Windows versus on MacBook. That's configuration.
That's compatibility. Because these are different environments.
But different softwares as well.
Yeah, it's also the software, but you know, you are just going to have one. You won't be able to have both, right? If you have Windows that's just one software. But compatibility is you're going to be testing it on different of these environments. You're going to be doing, like Linux, Microsoft, and all of these. Whereas the first one, if you're testing it yourself, you're just going to have one environment, unless you simulate all the different possibilities, which is not going to be possible. Whereas environment, you are actually simulating all these different possibilities, all these different software, right? You're going to test it on multiple browsers, right? Whereas for configuration, you're just, you already have a set of, software and hardware working together. You're going to go through multiple of these. So if by chance you have one of these software configuration, Microsoft, and one of these software configuration being, what did you say, Macintosh?
Yeah.
Then you're covering also compatibility. It's portable. That means it's work on both. So there can be some overlap. But the proper way of testing different environments is through compatibility testing. You can be lucky, in configuration testing that you're testing two different environments, but it can also not be the case.
Yeah.
You have a question?
What about different OS versions? Like, what would that fall under? Like,
Compatibility. Yeah, because you're testing different operating systems. Yeah. Oftentimes, not only in these type of tests, but oftentimes, different types of tests, there's going to be overlap. For example, the scenario that you mentioned, let's say hardware and software configuration, you're already testing 3 different operating systems. Then you're not going to do the same thing for compatibility testing, right? You've already tested 3 different operating systems, so you're not going to overlap the test. So it's already covered in some other type of test, you're just going to move to, pick and choose a different environment to run your test. So you don't want to lose time. That's something that resources is important. Any other questions, or can we move to test case design? Okay, if you think about anything else, we can take it at the end of class. Software testing has a lot of different, not a lot, 4 stages. The first stage, we start at the bottom here on the left, is test planning. This is something that you're already doing. Probably you did not call it test planning, but I asked you, if you remember, a couple of weeks ago, when we right after we completed software design, to start thinking about the features you want to test. Remember? Yes? Okay. So what I've been asking you to do in the first stage of software testing, I've been asking you to plan what features you want to test planning. So planning is basically that, what to test. Designing the test, you now have to start thinking, how am I going to perform these tests? Executing the test execution, this is what happened when you steal images of Google Images. So test execution is actually performing the test. And the last part is analyzing. So you analyze the test, and then you report the result. Meaning, have your test been passing or have your test been failing? And then, if your tests have been failing, when it should be passing, then if there are some bugs, right? You have to correct the bugs. So, typical design stages. I think this one is a little bit more formal. If I'm not mistaken, this might be the IEEE sort of, but don't take my word for it. I'll have to cross-check. I forgot to add a reference here. So different stages in test design, actually designing your test, as in here. So we're just going to focus on that. So first you have test strategy, then you have planning the test case design, not planning the test, planning the test case design, actually designing the test cases, and then you have procedures, which is basically executing the test and documenting the test. So we're going to look at each one, so it's going to bring a little bit more clarity about what is going on in each one of them. The first one is test strategy. So here you are going to start thinking about your overall approach to testing. Meaning, as a team, you're going to decide what type of test are we going to perform, what type of test makes sense. Do we need to perform unit testing? After unit testing, what are the components that we need to test in integration testing? Do we need to test the system on its own? Or, how much of the system do we need to do? Do we need to do just functional requirement or non-functional requirement? What are we going to do? What features are we going to run black box testing? What features make sense to do white box testing? So all of these are, like when you're designing I'm not going to use the word design. You're thinking about your strategy to testing. So you're basically designing your approach to testing. So you're going to decide on the type of testing. You're going to decide on tools, method, techniques, etc. I did not force anybody sort of to, it was not a requirement. Forcing is a little bit of a strong word. It is not a project requirement to do automated testing. Manual testing is fine for this class. I mean, we don't have enough time to do manual automated testing. But if you're familiar with automated testing, you want to automate part of your tests, go ahead and do it. But you will also have to plan whether you're planning to do things manually or automated, what tools you're going to use, what IDE you're going to use, and so on and so forth. But you're not going to be penalized if you just do manual testing. So this is, this is all going to be part of your software quality assurance strategy, software testing. So now that you've decided on all of this, you're going to have to start planning your tests in detail now. Now you know what type of tests you're going to do and so on and so forth, what type of tools you're going to use. So now we plan in detail. So basically I want you to focus on these like 4 bullet points in that second bullet points. So what you want to do here in software planning is decide what to test, the level of testing that you're going to be performing, the integration, system testing, the order in which things should be tested. So if you're doing bottom up or top down, what should be tested before you can test the next component? This is important. You cannot test, for example, something that's going to be very in-depth without testing the high-level features, right? Because before you can even access something which is in-depth, like maybe page 10 of your website, well, you need to make sure you can even access the first page, right? So what order of testing is also going to be important. Test environment, meaning everything we talk about just now in compatibility and configuration. So what are the different configurations, what are the different browsers, what are the different operating systems. So what is basically the test environment you're going to use to test your software. You'll need to write all of that down, for your report in the next milestone. And it doesn't need to be exhaustive. I'm not expecting 200 combinations of stuff. But if it makes sense, if when we're grading your stuff, the team is the one who grades your project. When they see that you've been thorough enough, you've at least have a few combinations of things that you've tested, that's fine. That's good enough. We don't need you to plan or spend a lot of time testing different environments. So the next step, now that you know what you're going to be testing and you've started to think a little bit about all the details, who's going to be testing what, the level, the order, the environment, now you actually need to design the test. So here we have a little bit of a more formal definition of a test case. So a test case is basically specifying the input, the conditions in which the test is going to be executed, and the expected results. So even before you execute the test, based on the requirement, you should know what you're supposed to get as a result. So let's say you have a search feature. Do you guys remember the cinema website, Cinemara or something? When you're searching for movies, what are you supposed to get? List of movies, right? You already know that. You don't need to run the actual test. So this is going to be basically, if you have some input, you're going to have, you're going to know what input you're going to try. You're going to have your execution cycle, right? This is the first step, second step, first step. And you also should know what are the output that you're expecting. Actual output is a different story. Expected output, at least you should know how the software should behave. Another thing to remember is that you should do both positive and negative testing. What does that even mean? Yeah?
Tests where you know you wanted to fail, negative, and positive tests where you wanted to succeed.
Yeah, so basically, not you want it to fail, but the software is going to fail. For example, let's say last name. Let's say everybody has regular last name. Last name should be a bunch of letters, 10 characters. So you are expecting when you positive testing, you give it a name, right? Smith, it's supposed to pass. But if you give it a bunch of numbers, it is supposed to fail, right? So you give it things that it is supposed to do, accept a bunch of letters, positive testing, give it a bunch of numbers, negative testing, it is supposed to fail. Now if it passes, there's a bug in your program, right? So we're also going to have a look at some of these examples. The last one is documenting. Again, don't be scared. Documenting a test case, it should include some of these details, not everything, because this is exhaustive. Probably if you work at a company, you're going to provide this amount of detail. I'm not expecting this amount of detail. Sometimes some of these will be automatically generated. So of course, what I'm expecting is every test case will have an ID, so we can refer to it. A requirement 1 has been tested using test case, ID 1, ID 5, ID 7, etc. The title of the test, okay, I am testing the login page, things like that. Related requirement, you can, add this is for traceability purposes. You still remember the traceability metrics? Just confirm something for me. You guys haven't started studying for the midterm, right? Or you're scaring me here. So traceability metrics would be something like this. You would have your, we talked about it in the requirement lecture. So you'd have your requirements, blah, 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 and then you would have other requirements, the same set of requirements. So here, what we talk about the requirement, the traceability metrics is that, for example, if I'm changing requirement 2, what are the impact on other requirements? So you would have like a cross here, a little check here, and things like that. So at a glance, you can see if I'm messing up with requirement 2, I will have to check that requirement 1 is not impacted and requirement 3 is not impacted. Similarly, if you're going in this direction, you're changing requirement 3, you're going to see that requirement 2 is being impacted by your change. So this is a traceability metric. I can't remember which lecture it was, but it's there somewhere. Okay, so this is what it meant by having the related requirement, like this test is affecting what requirement. So in a traceability metric, you can have requirement linked to requirement, you can have requirement linked to design document, you can also have requirement linked to test, and this is basically what they're talking about here. Priority of the test, is it like a high priority test because it is a critical feature that we're testing and things like that. So you can decide what are the steps. We're going to see in a minute like what we're talking about in steps. What is the initial data, the expected result, the status, all of this we're going to see for an example. And often, normally when you write code, you would have at the top, right, your name, date, and what it is doing, some documentation. Ideally, right? Ideally you should. So similarly in a test, you would be reporting who is performing the test, or who is designing the test cases, who is actually assigned to perform the test. So as I said, this might be a little bit of an overkill, but at least for your project, have a little bit of documentation. Just don't give me like a spreadsheet and no head, no tail. I have nothing. Your team won't have any idea like what's going on. So I want to give you an example next. So let's say we have to test this login feature. Pretty straightforward, right? We all are familiar with the login. You put in your username, the password. When you click cancel and it is the right username and the right password, it's supposed to take you to the next page or whatever, right? And if you press cancel, nothing's supposed to happen. This is something we all know. Before we even go and look at the test case, how to design the test cases, and without moving to the next slide, look at these 3 questions and tell me, even before, how did you even know what features you needed to test? Where did you go and find this information? How did you know the steps for testing? And how do you know the order of the steps? How do we even know there's a login feature to test?
Gut.
Your gut? Gut feeling? Yeah, you should trust your intuition. Sometimes it works. Well, it's your project, you would know, right? How would you know? Somebody who doesn't know, like a team of independent testers. How would I know there's even a login feature to test? Where would you find this information?
Documentation.
Which documentation? There's a lot of documentation. Which one? What did you have to write to tell me there was a login feature?
The class diagram.
In the class diagram you would find it. That's true. Yeah.
Requirements.
Your requirements, yeah, there's a couple of places you can find it. So if you remember the, where's that chart? In the class diagram, hopefully you remember, you would have the class name here, you would have the attributes here, and then you would have the methods here, right? Normally in the methods, you would have a thing which look like this, right? So how do you know there's even a login feature to test? SRS stands for Software Requirement Specification, which is basically your requirement. Class diagram, you will see a login method, use case, high-level use case. In one of the scenario, you would have a login when you're building the use case for the entire system, not the use case for the login only, for the login process, but the entire system, right? All the features. How do you know the steps? Well, you would see either the low-level use case, because this is where the login is described in detail, sequence diagram, activity diagram. The order you would only be able to see in the sequence and activity diagram. So activity diagram, we would follow the arrow. Sequence diagram, because it moves across the time dimension, you would again follow the arrow horizontally, sort of going, and then the dash arrow back. So basically, you'd just be following. You would know what comes first, what comes second. Do we see how the beauty of software engineering, how all these things are related? Okay, so let's, don't be scared. This is basically testing the login. So I'll give you a minute to look at that, because I'm not going to read all of that. Done? Well, at least you have an idea. So when you're testing something, you as the end user, when you're logging into something, you put your correct username and password, and then you press submit. But as a person who's building it, there's much more which goes on behind the scene. You have multiple combinations that you'll have to exercise, and each one of them is a separate test case. So TC means test case 1. So you would try with a valid username, valid password, and then you press submit. You'll try with a valid username, invalid password, you press submit. So all these different combinations. And then you'll repeat the same thing with the cancel button. Just imagine, because somebody has copied the code from the submit button to the cancel button, you actually, like let's say you do something like valid user ID, valid password, and then you press cancel and it logs in. Because somebody duplicated code. Well, if you didn't test it, you wouldn't know, right? So I have a little note here. So you would see that, I have some blank, like TC0506. Why am I looking there? It's right here. TC05, TC06, you have some blanks. So if you have defined blank as, being a subset of invalid, then, by saying invalid, as in TC08, you're already covering blank. But that's not for me to decide. It's based on your definition. What does invalid mean to you? Is it including blanks, or blanks is something separate, right? So depends on your, not even on you, depends on your customer's requirement. So as you can see, something as simple as a login can have, probably at least 20 test cases. So how do we represent our test cases? Basically, what do you need to do for your project? Something as simple as a spreadsheet. I'm not expecting something very complex. If you want to use tool, be my guest, but something as simple as a spreadsheet should work. So here I have 2 different scenarios for the same test case. So you can use something like that to document, that's fine. I have a test case ID, I have the test scenario that I'm testing, I have the test steps, I am providing the test data, I am providing the expected result. So basically all of that in expected result you can even write now before you even perform the test. You can build that spreadsheet for that, first 5 columns. After you perform the test, then you write the actual result and whether the test is passing or failing. So let's look at the first one. So 2 scenarios. The first scenario, the top table. You have the test case ID, and the test scenario here is that we are checking the customer, the login with valid data. So the steps, it might be obvious for login screen, but some of your features might not be so obvious. So the steps the tester needs to perform is go to the login page, enter the user ID, enter the password, click submit, and and then they are going to have the test data. So you're going to provide it with valid data. Remember, the test scenario is valid data. So let's say that's the right username and the right password. So when they enter number 2 here, when they enter user ID, they look at the test data. When they enter password, they're going to look at the test data that you have provided, that you've written. And the expected result, what you're expecting even before running the test, because these are the correct credentials. So it should go through, right? You should go to the next page or the next whatever you are expected to see. So now you actually run the test. You follow all these steps, you give it the data that have been provided to you, and yay, it works. So the actual result is as expected, meaning the user is able to log in. And that means the test has passed, meaning you got the result that you were expecting. The user is supposed to log in reality, they have been able to log in, so that means a pass. The next scenario, the one at the bottom, everything is exactly the same. The user has entered the correct username and the correct password, but probably, let's assume, somebody exchanged the code for the submit and the cancel button. When they press submit, the user cannot log in. So that was not supposed to happen, right? The user was supposed to log in. So that means in that context, the test is failing. It is supposed to pass, it is failing. So this is where you go back and fix your code. Okay? Question? Yeah.
After you fix your code, do you go back and change the actual result?
Yeah, you do retesting. Yeah. You're going to have multiple versions, right, of testing, multiple times. This is why also we do regression testing, right? You rerun these tests. Yeah.
Kind of a bit more related to the previous slide. So in the login, how you were telling us even about the login, there's like 20 different tests because there's different combinations. Right?
Yeah.
Is there any, like, you know how in coding we have for loops, while loops, is there anything in testing where you can
This is automated testing. This is where you do automated testing, so you don't have to actually run those manually.
Oh, okay,
Just providing you like test data and different combinations.
Yeah, exactly. That's
Yeah.
what I was.
But since like not everybody is familiar with, and you need to understand the logic, right? This is an intro software engineering course, so you need to understand how to start thinking in terms of testing before you even you're walking. If some of you are familiar with like automation, test automation, then feel free to have some automated tests. But it's fine if you give me something like that. I want you to basically what I want to develop in this class is that logic of let's think about how we can test, not like let's run and use some tool to test, but understanding like the logic, being in the sort of putting yourself in the mind frame of a software tester. Yeah, but yeah, that's why automation testing. Okay, so now that we've finished that, normally at this stage you would have column 1 to 5. You haven't done the test yet. So now that you have designed the test, you would actually write the steps for conducting the test, right? Who is going to conduct the test, what in order, which one you're going to test first, and so on and so forth. And then the last stage is actually performing and documenting the test results. Why is it important to document your test results? We talked about that last time. What happened to the test after you run it? We had a slide which said, tests don't die. They don't die. Because software is developed over 6 months, 1 year, 2 years, but it is maintained for 10 years. In the case of banking software, since 1978, they're still using the same thing. So your tests, you have to document your test results, because as he pointed out, you're going to have to rerun the test multiple times if things are failing. And they don't die. They're going to evolve over time. They're going to be modified. More stuff are going to be added. More test scenario, more test cases are going to be added. So then you need to document your test and your test results. Okay, any question before we move on to code review? Okay. So testing catches error. As we have seen, it's going to catch error in parts of the software that you have exercised. If you haven't tested something, it's not going to find the error. And sometimes, if we don't pay close attention, let's say a very simple example that you'll understand. Instead of adding 2 numbers, somebody, instead of the plus sign, somebody added a minus sign. Is it still going to give you a result? Yes, it's going to give you a result, right? Instead of adding two numbers, it's going to be subtracting the numbers. But is that the correct thing? Is it supposed to subtract when it is supposed to add? Right? You're going to get the wrong result. But it's not going to crush the program. So if you did not pay attention, you're looking at, very quickly, you say, oh, number 5 here. Should be good, it's not crashing. But you won't actually see that it's not actually adding the numbers, it's minus, and it's doing like a subtraction. So some little things like that. And this is just a simple example, but real code is not as simple as that. There's going to be logical operation, there's going to be things that you're going to miss, logical things that you're going to miss. And this is where things like code review, code inspections, walkthrough, we're going to distinguish between these three, comes in handy. What's the difference between these three? These are all concerned with like inspecting code, but they are slightly different from the other. So, we are doing things the proper way here, so we can't say she didn't teach us the difference between walkthrough and code review. So at least we have that covered. So walkthrough is a very informal. So this is basically when you're changing a couple of lines of code, and it's just you and your friend, he's checking what you've done. So this is the most informal of, all the sort of reviews. So these are also called desk checks or code reads, and normally performed to confirm very small changes, a couple of lines of code, usually involve two people, you and your reviewer. And normally when you're doing peer programming, it's sort of intuitive, it happens naturally, you don't need to perform separate walkthrough. The one that you're going to be performing for your project is code review. So this one involves when you're changing, a bit amount of code, substantial amount of code, or you're adding new stuff, and then you want to see how, whether the code that you've added is good code, you're following all the design principles, solid, dry, KISS, YAML, ring a bell? So you're following all these like software engineering best practices. So these are all you can incorporate into code reviews. So here you've changed substantial amount of code. Somebody else is going to review your code, and normally this is a formal review meeting, and this is basically what you'll be doing. Like everybody's present, you're going to review the code, everybody's going to listen and see, okay, this is what is going on, and so on and so forth. But we are going to try to decentralize it, so everybody's going to review the code of somebody else, and not everybody's going to need to be present. If you've read the description for the milestone, you'll have to review each other's code, right? Yes?
Solid, dry, are those required on the midterm?
Huh?
Solid, dry, are those required on the midterm?
What the?
Midterm.
Yeah, this is software design.
But like what kind of question have we got about those? Like what?
We're going to cover that later. Let's finish this. We need to finish this so you can start working on your code review. Okay, so inspection is the most formal type of review. It's called inspection. It's different, but you will see that oftentimes when programmers talk about this, they're just going to refer to it as code reviews, right? So the purpose here is to find defects in documents as well. So walkthrough and code reviews are mostly sort of restricted to code, but inspection, this is where you're going to also look at your requirement document. So documentation in addition to code is also sort of thrown into that batch. So planning documents, your user stories, your epics, your personas, your software architecture diagram, all these different UML diagrams, the code itself, the test cases, all of these can be reviewed. So basically any work product, or nicer term to use, any software artifacts that is produced during development can be inspected. But in a project like your team, we don't usually do inspection, even like regular, or industry just building like regular software, you're not going to do it. This is inspection, the most formal one, is usually kept for mission critical, safety critical software where something happened, it is going to cause lots of money and maybe even loss of lives. Yeah, this was the best part, right? So it is more time consuming, takes more resources, a lot of people are involved because you want to really make sure you have inspected every single line of code of that car braking system, right? So people don't die, or that, like airbag, airbag, I don't even know what it's called, ABS? Is that ABS? I have no idea. You know what I'm talking about, right? I don't know much about cars, but you would know what I'm talking about. So it is, there is a formal sort of description. It's actually called, it's actually by Fagan's process in 1976. So if you want to look up inspection, have a little bit more detail, so that's a good reference. So in all of these techniques, they do not replace software testing. They are complementary. Software testing is actually going to exercise the code. Here you're just looking at each line of code and making sure things are, according to some. I'm not going to go over rules here. I'm going to talk about it later, but according to rules that have been set up by the project, by the company. So next, I want to go over a little bit of some, research data. So here in 1999, a study was performed to show that the cost of defects is lower when actually people perform inspection. So at the top in green, you're going to see the total cost of defect is $738 with inspection, and it's $2,177 without inspection. So if you want again to read a little bit on this, you can look at the reference. I have some more data here, and each one has the reference at the end. But they are all taken from this book, Code Complete. So if you I don't know if you've checked the schedule, but the next lecture is called Clean Code. So in Clean Code, we probably are going to cover this entire book in one lecture. We're going to do a lot of it. So how to basically write clean code, and you'll go back, and clean your code hopefully after that. So, so this is from the. So if you're really interested in pursuing a career as a software developer, software practitioner, this is a book that should be on your bookshelf. How to write good code. So a couple of, I'm not going to go through all of these, but research has showed us that inspection captures, inspection meaning walkthrough, probably not walkthrough in the rigorous sense of it, but reviews and inspection captures about 60% of defects, in addition to to other techniques, except for maybe things like prototyping and high volume beta testing. If you're doing beta testing with 3 users compared to hundreds of thousands of users, it's not going to be the same thing. When you inspect design and code together, it removes about 70 to 85% of defects in a product. So it helps you identify, inspection helps you identify error-prone classes early. So all of these are, statistics from research. You can go over those on your own. I want to move on to the different roles during a more formal inspection. A lot of different types of people are involved in an inspection. You're going to have somebody called a moderator. The role of the moderator is basically, he's the one conducting the review. He's like the review lead, the inspection lead. What he's going to do, he's going to talk to the author, meaning if you look at the second one, the author is the one which has something that needs to be reviewed, either some design document or either some code, right? So the moderator is going to come to the author and say, hey, give me whatever needs to be reviewed. So he's going to make copies, distribute it to the reviewers, plan the meeting, the inspection meeting, book the room, look at all these logistic things. And then after the inspection meeting is done, he's going to follow up. Make sure, if some issues have been caught, somebody is actually doing something about it. What's the purpose of, somebody spending a few hours finding issues in code and nobody ever do anything about it? It's a big loss of time. So the role of the moderator is also to do that, follow up on these sort of action items. We talk about the author. So the reviewer is anybody who has to review, whatever has been given by the author, design or code. And then somebody who's maybe a little bit you're not familiar with that term. During the inspection, there's going to be somebody who's going to take notes. All the issues that have been found is going to be documented, and who has been assigned to do what in that meeting is going to be documented as well. And that person is called a scribe. Normally, it's not a good idea to involve management because people might feel they are being, they might feel they are being evaluated instead of their work product, meaning their code or their design being evaluated. It's especially let's say you guys, you graduate, you join a company, probably, no offense, your code is not going to be the best quality because you're still getting used to the code base, you're still making like mistakes here and there. So let's say you are your code is being inspected, you won't feel too good. There's probably going to be a lot of issues, and now your manager is there, right? So it's not going to be the biggest boost of confidence, right? So you don't want management to be there. But one thing to remember is nowadays everything is centralized. There's dashboard of just about everything. So then they probably will have access to your inspection report. So we don't want them to be in the meeting, but somehow they might be still able to access the report. So this is a little bit of more detail, how the inspection actually works. So the planning phase, the moderator is going to come to see you, the author, to give them the design of the code. The moderator is the one who decides who is going to be the reviewers, so they're going to pick a few reviewers. They're going to schedule the meeting, book the meeting room, distribute the, whatever needs to be reviewed, and a checklist. Bear with me on that one. I'm going to talk about a checklist probably in the next couple of slides. So the moderator is going to give you, okay, this is the piece of code that needs to be reviewed. They're also going to give you the checklist. So normally that next step should not be required because your code or your design should speak for itself. If you as the author have to come and explain your code and your design, that's probably not a good sign. It's probably not very good quality of code, or the design is not very sort of intuitive. But if needed, the author may need to provide some context, some overview to the reviewers. To prepare before the inspection meeting, the reviewers will need to actually perform the job, do the review. So each reviewer will work on their own to look for errors using the checklist. So this step is what you are going to be doing actually individually for the code review part of the next milestone. And there is a best practice here. So if you want to get an idea how much time you're going to be needing to review code, about 100 to 150 lines of code can be reviewed in an hour. So this is sort of a best practice. And the reviewer may need to give you code, may decide to give you code to different people. Some developers, some architects, some maintenance people, some testing people, so you get different perspectives on your, whatever artifact need to be reviewed. So this is prep before the meeting. Then we have the actual meeting. So the moderator is going to pick someone to explain, the thing that you are supposed to review, meaning the code or the design. So somebody explains, and then the reviewers start telling what issues they found, and the scribes start noting down. So you may note different level of detail here. You might note, oh, this particular issue is in a critical feature of the software. So you might be noting down severity or urgency or priority, type of issues, right? So this needs to be fixed urgently. So you will decide, what sort of information you will want to add to your report when you actually produce it. The thing about inspection meetings is that you just discuss problems. You don't discuss solutions. If let's say you as a junior developer, you don't really understand what's the best way to do certain things, that's why it is the way it is, then you have what is called, you schedule a separate third-hour meeting, where this is the meeting where you can discuss solution. But normally in the inspection meeting, you just pinpoint all the different issues. Normally an inspection meeting should not last for 2 hours. And the next thing is the report after the meeting. So the moderator is going to produce the report. It's going to list all the issues that have been found, and any additional information that you've recorded, the severity of the issues, where it is located, what type of issues it is, etc. And then normally these inspection reports are used to, make the checklist better. We're going to see the checklist in a minute, just a little bit of patience. Once this is done, this is the most important step. Somebody has to take action, right? The author normally is the one which is produced with that inspection list, and you have to fix this, you have to fix that. So they'll need to go back and fix it. Else it's going to be a loss of time that you've lost in the meeting, loss of time of each reviewer who spent maybe hours reviewing your code. And then it is a job of the reviewer to actually follow up with the author. Is the author actually doing the work, right? Maybe see after a couple of days what percentage of the work has been done after a week or so. And normally you would tell the author, okay, you have 3 days to implement this. You don't just give them like forever to implement, right? You need some sort of deadline. So when you are doing code reviews or inspection, you often have some best practices, and this is basically a list of best practices. How to make your inspection effective? Well, you will need to have a checklist. You will need to focus on finding the issues, not discussing them. So a little bit of things that we have talked about. Did you give the reviewers enough time, or you just handed them the code during lunchtime and say, hey, we are meeting at 1, review this during your lunchtime? They probably won't do a good job, right? Is the meeting limited to 2 hours? So all of these are best practices that has been compiled by not me, by software engineers in the 50 years that software engineering has existed. So we have some more sort of, what makes a good inspection here. So in the second and third bullet points, you'll see that they'll also collect some data, some metrics about, the type of errors, the quantity of errors, inspection rates, how many, how much time we spend on this. So they're going to collect some metrics, or even when they analyze the different inspections that have been carried out over time, they can extract some data. So there are more metrics here. I'm not going to go over it, but you can actually take, collect metrics over time. So the checklist, the famous checklist. So there are many checklists. This is sample 1, which has different sections. Oh, sorry. You're going to have a general section. For example, you are going to have questions like, is there any redundant or duplicate code? Or can you replace any of these global variables? Do you have huge pieces of commented out code that you can remove? Do you have unnecessary documentation, right? Like lots of comments which people have already addressed that needs to be removed. Is the indentation correct? Or things like that. And then you can have other part of the checklist. If performance is a big fit for you, you can have a section of your checklist being on performance. You can have security things. You can have documentation. You can have testing. So what is going to go on your checklist, your team need to sit down and make that checklist. You will know, depending on your project, what goes in your checklist. And as a team, you'll need to work together, produce that checklist. The second step of the code review, now that you have a checklist, every single member is going to take that checklist and review each other's code. But it's going to be the same checklist. So this is a checklist which is a little bit more generic, general. Now you have a checklist which is sort of programming language specific. And this is just an example of Java. You've implemented, in other programming language. Google make a style guide available with all of these, and this is the link there. So you can check, and don't just limit yourself to these 2. You Google, like code review checklist, you're probably going to get a bunch. So make your own code review checklist, and don't give me just two items on the checklist. Make sure it's at least a page, right? You've checked, you've done a good job checking, your code. So you'll design your code review checklist as a team. You'll give it to each member. Each member is going to check, like when you start doing your code review, let's say you're using something like that. So you're going to see the first one. Are descriptive identifier names used in according to naming convention? You're going to look at the code that you're inspecting, or you're doing a code review and seeing if everything is there. If not, you're going to document. You're going to have to produce a report, right, following your code review. So these are the things that you're going to write down. So don't just copy. If anybody gives us like an exact replica of something that is online, guess what? Your grade's going to reflect that. We don't want that. We want you to take a checklist available online, make sure you cite the source, but adapt it to your project. It can be, a lot of them can be borrowed. Of course, you're not going to invent things which is already existing, but make sure it's adapted to your project. Performance is not going to matter for everybody. Security is not going to matter for everybody, but it's going to matter for some of you. So one thing about code reviews, you're going to be performing code reviews, and something that I always tell you, I'm not interested in these classes, but who is the best at Java, Python, or who knows, like how many programming languages. What I'm interested in is the soft skills that you are building in this class. So make sure you don't kill each other, right? Be civil, be diplomatic. So these are some of the quotes that I've taken from a Microsoft blog on Microsoft article on how to perform code reviews. You can read it. So respect others. Don't take anything personally. Don't forget your own working towards a common goal, improving the quality of the software. We all make mistakes. What is important is to learn and improve and treat others how we'd like to be treated. So be respectful. Make sure each feedback is actionable, is concrete. Oh, X is not right. Y is not right. Why is X not right? Why is Y not right? So you have to, it shouldn't be your opinion. It should be supported. Like when you're writing your report, you should have, some concrete stuff, like some concrete action. So explain what could go wrong and why the code needs to change. And you can communicate your context. For example, based on this best practice, you're not doing that. So we have used something in the past and it failed because of that reason. So you can give them that, yeah, I've seen this before, it has failed before because of X, Y, Z. Oh, I have read an article. Or you can even cite the lecture notes. According to the DRIVE principle, this is not what you should be doing. Single responsibility principles and things like that. So, we have a couple of slides here, static code analysis and metric. I'm going to cover it in the next lecture. Something that I want you to start working at home, and we're going to go over it first thing in class next Tuesday. We still have 3 minutes left. So you will have to build a test case for that. You remember that, the ATM, right, example? So if you look at the test case, there are 2 types of test cases I want you to build. And I have often given questions like this in the exams or in the midterm. So it's in your best interest to start thinking about it. So I want you to derive some test cases based on the functional requirement, which is cache withdrawal. But I also want you to start thinking about how am I going to test non-functional requirement. And I want you to focus on performance non-functional requirement and security non-functional requirement in the context of the cache withdrawal. How can I test for performance when I'm withdrawing cache? How can I ensure security? What are some of the tests that I need to perform? So think about it, we're going to go over it in class. So that's an exercise. And if you haven't read that article, we are also going to look at some best practices on Tuesday. So make sure you read that. So next week, same milestone, by next Friday, product alpha testing code review. You don't have any reading. I want you to focus on studying for your midterm. And on Tuesday, the last lecture before, I know it's not the midterm, but before the break is going to be clean code. And make sure you are on time for your respective sections on next Tuesday. If you're planning to disappear on Tuesday, next Thursday, if you're planning to disappear on Tuesday. Any questions? We have a minute.